For generations, humanity dreamed of flight, and Leonardo showed us how to imagine the impossible. But dreams alone were never enough. To turn inspiration into reality, the world needed something else: a rule, a principle, a law. A burst of blinding light fades, and a quiet bell rings in the darkness. Then, he opens his eyes. In a small room in Cambridge, Isaac Newton awakens to a new way of seeing, not a world of paintings or dreams, but a world of forces, of numbers, and of perfect rules, hidden beneath every motion. This moment marks the beginning of a new age, the age of precision, the age of the clockwork universe. Before Isaac Newton reshaped our understanding of the universe, another revolution had already begun, a quieter one, a revolution not of machines or inventions, but of measurement. For centuries, people watched the world move, without truly knowing why. Objects fell. Pendulums swung. Planets drifted across the sky. Motion was familiar, yet still mysterious. And if motion could not be measured, it could not be understood. The first breakthrough came from a simple rhythm. Galileo noticed that no matter how wide a pendulum swings, its timing remains almost constant. A discovery so small, yet so profound, because it revealed something new. There is order hidden beneath motion. Soon, others joined the pursuit. Christian Huygens built the first accurate pendulum clock, a machine capable of measuring time with unprecedented precision. For the first time, the world had a heartbeat it could rely on. Seconds became regular. Minutes became predictable. And time, once a fluid and shifting idea, began to take a mechanical form. This was the dawn of a new way of thinking. A belief that nature might follow strict rules that could be calculated, predicted, and trusted. Across Europe, scholars refined their tools, sharpened their mathematics, and tested the world with increasing discipline. Lenses improved. Telescopes grew stronger. Measurements became sharper and sharper still. But even with these tools, something was missing. They could record motion, but they could not yet explain it. Every falling apple, every swinging pendulum, every orbiting planet. All of them hinted at deeper truths. Truths waiting to be understood. Nature was whispering its rules, but humanity did not yet understand the grammar. And this is where Newton enters the story, not as an inventor, but as a translator. When he looked at the world, he did not just see motion. He saw structure. He saw relationships. He saw patterns others had observed, but none had fully decoded. The work of Galileo and Huygens had built the instruments Newton would supply the laws, and with those laws, the universe would change forever. When Newton began to write, he wasn't simply describing motion. He was decoding a language that had existed long before humanity learned to hear it. He started with a single question: what makes things move, and what keeps them moving? To answer it, he looked not just at apples and pendulums, but at cannons, tides, falling stones, and the turning of the moon. Every motion, earthly or celestial, became part of a single investigation. And from that investigation, Newton uncovered the grammar of the universe. 3 laws: simple, elegant, absolute. The first law: an object in motion stays in motion unless something interferes. For the first time, rest and motion were part of the same rule. Stillness was not special. Motion was the natural state of the cosmos. The second law: force equals mass times acceleration. A sentence so short, yet powerful enough to describe every push, every pull, every collision, from a cart rolling across a courtyard to the trajectory of a comet slicing through the night sky. The third law: for every action, there is an equal and opposite reaction, a truth that binds every interaction, from the strike of a hammer to the dance of planets around the sun. With these 3 laws, Newton did something extraordinary. He stitched together 2 realms humanity had always kept apart: the heavens above and the earth below. The same rules that governed falling apples governed the orbit of the moon. The same mathematics that described a cart on a wooden floor described ocean tides pulled by a distant sun. For the first time in history, the universe was not divided. It was unified. A single, coherent machine. A clockwork. And if the universe was a clock, then each motion had a cause. Each force had a partner. And every event, from the smallest to the grandest, was part of a vast and predictable structure. Humanity had always looked for meaning in the sky. Newton gave them something different: a framework, a way to predict the future, a way to measure the past, a way to understand why everything moves as it does. His laws were not inventions. They were translations, the first clear sentences written in the language of nature. And once those sentences were written, the universe would never look the same again. The moment those sentences were written, the world changed shape. For thousands of years, humanity looked at nature and saw mystery, chaos, motion without cause. But now, for the first time, there was a framework that connected every piece. A falling object, a swinging lamp, the tides of the sea, the orbit of the moon. All of them followed the same rules. Rules that were simple, beautiful, and universal. And the greatest shift was this. The universe was no longer a realm of miracles and whims. It was a realm of relationships, of forces, of symmetry. It became something humanity could measure, something it could predict, something it could trust. Across Europe, knowledge accelerated like never before. Engineers refined machines. Astronomers expanded models of the heavens. Navigators redrew the oceans with new accuracy. Architects designed structures with unprecedented stability. A quiet revolution unfolded, not in the streets, but in the study rooms, workshops, laboratories, and observatories of the age. A new world emerged, a world built on precision, a world that behaved like a machine, a clockwork. And with this revelation came an even deeper truth. If the universe could be described with mathematics, then the future could be shaped by mathematics. Every measurement improved the next. Every calculation unlocked another. Every discovery expanded the boundaries of the possible. The age of uncertainty was ending. The age of prediction was beginning. And from this foundation, from these simple, elegant laws, would rise the engines, instruments, sciences, industries, and technologies that would transform human destiny. This was not just a scientific revolution. It was a transformation of the human mind. A shift in how civilization understood itself and its place in the cosmos. A shift that still defines our world today. The universe had become knowable, and once it became knowable, humanity would never be the same. And so, the age of precision began. An age where the universe could be measured, understood, and trusted. An age that reshaped our world and forever altered the destiny of our species. But this transformation, this awakening of the human mind, was only the beginning. Because once humanity learned to harness motion, it began to wonder, what if motion could be captured? What if it could be amplified? What if it could be turned into power? From quiet studies and candlelit observatories, our story would soon descend into furnaces of iron, into mines of coal, into workshops filled with heat, smoke, and the first engines of fire. A new force was waiting to be discovered. a force that would shake kingdoms, ignite revolutions, and give birth to the modern world. The next chapter begins where motion becomes energy, and energy becomes power. Join us as we enter the revolution of steam.